We got some solar stuff in the mail. And there's the panel. Let's open it up, take a look inside. Okay, and surprisingly the box is not taped shut. It's just latched shut there. And there's the panel right inside there. So let's try to pull it out, make sure it's all in one piece. And there it is. It's a 100-watt panel, the Renogy 100-watt RNG 100D SS high quality solar panel. And here's the back side of the panel. It's got the connectors there. And you can see, if you can read that, it's max power 100 watts. Open circuit voltage is 24.3 volts, 5.2 amps. This is aluminum. Some mounting holes here, which I may or may not use. I may have to make my own. And here's the solar panel here. The solar panel is going to get mounted right over there on that rail right there. So what I need to figure out here is where exactly the wire is going to go into the boat. So the wire is going to come out here somewhere, and it's going to need to go somewhere into the boat. I have to figure out where that is. Okay, so here I am on the boat. I got most of the pieces that I need for the solar project. First is this thing here. It's the charge controller from Victron Energy. It's a 7510 charge controller, and it's the smart one, which means it connects to Bluetooth so you can see what's happening on your phone. The 75 is for the volts, so it can handle up to a maximum of 75 volts, and the 10 is the amps, so it can handle up to 10 amps. It's an MPPT controller versus the PWM controllers. So the MPP is something like point tracking or whatever, and what is supposed to be the smart version of the two. The PWM charger is a pulse wave modulation charger, and the difference is this one here reads the voltage of the battery, and it applies the right amount of voltage that the battery needs to charge itself, whereas a PWM charger doesn't do that. It just keeps on feeding the same amount of volts and amps to the battery all the time until I guess it cuts off. But this one is supposed to be smart, and it will better charge the battery, and you can also program it to charge certain types of batteries. Like I have AGM batteries, so you can program it to specifically charge AGM batteries to their optimum charge. And it's pretty simple. The battery, two battery terminals here, the cell goes here, and then something else goes there. I don't know what that is. I don't think I need to use that one. And then it's Bluetooth, so once you plug this into the battery, you can turn on your phone and pick it up and then see like the data. It saves the data in the memory of this thing, and you can see how the charge has been over the past week or so. Next thing I've got in here, this is probably unnecessary, and I'm debating whether or not I want to put this in. But what this is a breaker. If I can get it out of the box with one hand, there we go. So it's a box, and the breaker goes inside here, and this is the breaker, and looks like that. So it'll go inside there, and then this thing here would be used to shut off the power from the solar panel. So if you look like on like if you put solar on your house, or if a lot of people that put them on vans and RVs and stuff, they'll put these in there, and by code, electrical code for a house, it's required that you have a shut off between the solar panel and the charge controller here. So what would happen is you'd have the solar panel over here, the wire going to the breaker box, and this wire going into the charge controller, and the charge controller going into the battery. And there should be a fuse going between the charge controller and the battery. So this part here is probably not necessary on a boat. In fact, I was watching the I think it's called Pacific Yacht Systems Jeff Cote has a YouTube channel where he talks a lot about boat electronics or boat electrical things, and he says it's unnecessary. He doesn't use one, because if you need to shut off the power for the solar panel, you just cover it up, so it's not producing volts anymore. But if you ask anybody who puts it on like a RV or something, they will say you need to have one of these. So I'm kind of debating whether or not. I got one big enough that I could add to it. So this is a 6-way box, so 2 poles for the positive and negative, and then I got enough to go for 2 more beyond that. So because I planned it to expand the solar system in the future. This charge controller here, I opted for the smaller charge controller. This is going to be only for a single panel, so it's plenty big enough for the 100 watt panel that I have. If I wanted to add more, I'd have to get another charge controller, which they say is actually better to have more charge controllers, because say if you have 2 panels going to the same charge controller, if one panel gets shaded, then all the other panels are affected by that. But if you have your panels on different charge controllers, then if one panel gets shaded, then it doesn't cause a problem for the others on a different charge controller. So that's why I want to opt for more and smaller charge controllers versus one large charge controller for everything. So this is where everything has to go. This is the current setup for batteries. So I've got my number 1 house battery here, my number 2 house battery here, the number 3 house battery back there, and the starter battery here. And the way that this is set up is the starter battery is charged by the house batteries using a DC to DC charger. It's a Xantrex Digital Echo Charge, and it's got the house battery runs to it, and then it runs a wire to the charge battery. That's what these 2 right here are. The one problem that I think I have here is when they added this 3rd battery, they just kind of plugged it in, it looks like, to a couple of the batteries. They tapped it into the negative on the starter battery, which is connected to all the other batteries, and then they put the positive to the 2nd battery. So it isn't really hooked up truly nicely or prettily in a parallel circuit. It's not a series circuit either, but I mean it's parallel technically, but this battery is kind of isolated in that chain, so that affects the way they're charged. So when the batteries are charged, they don't get evenly charged. I think to fix it, all I need to do is move one of the negatives off the starter battery over to battery 2 and figure out where all these things are coming off the battery. So for example, here, this is the positive 1 battery here, positive 1 terminal. And so what should be happening is all the positive power to the boat should be coming off this 1 terminal, and then all the negative stuff should be coming off the last battery in the parallel. So that should be number 3, but as you can see, there's only 1 wire hooked up to the number 3. So and what they've done instead is most of the stuff from the boat is actually coming off the starter battery. So I'd like to get, even though I think electrically it's the same, I'd like to get all that stuff off the starter battery negative and then put it onto the number 3 battery. So what I've done is I've tried to label everything as much as I could here and try to figure out where all these wires are going, and then I'm going to try to draw up a schematic for this the way it is now and see what changes I need to make it a little better and also make it a little prettier. And what I had originally planned is to take that charge controller and everything and put it back in here on that bulkhead. So it's supposed to be relatively close to the batteries, so that gets it close to the batteries. The other thing that I need to do though is I need to put a fuse on that goes from the charge controller to the battery. And what I wanted to do is, right now you can see like there's a lot of stuff that's hooked to the battery right now already from different things, like the bilge pump and the alternator and the battery charger, and all these things are hooked up to these. And I wanted to kind of reduce the number of things that I have bolted to the battery by taking these things to a bus bar, like a positive bus bar. So that's kind of what I want to try to figure out now is what am I going to use to get this fuse in there, as well as reducing some of the wires and cleaning up some of the wires that I have in here already. Other thing that I kind of want to look at is the way these batteries are secured. They're jammed in there pretty tight. They're secured with this thing, which I'd like to come up with something better than that. They have a block of wood that's separating them in there. So I wanted to kind of clean it up a little bit and make the attachments a little better, I guess. All right, so part one is done. And what I've got in there so far, I went ahead and mounted the breaker in there. I want to go ahead and use that. And then in over to this side is the charge controller. So that's kind of my next plan, is to get a fuse box, put it on the inside there, and then start running some of these wires from the battery into the fuse box. All right, so I'm about halfway through this solar project. I have almost everything mounted inside the boat that I need to mount. All right, it's day 2 of the solar project, and what I got for today, picked up a couple things online over the week that I need to add to the system. So I've already got on there the shut-off switch that goes from the solar panel to the charge controller. I got the charge controller mounted, and I got a fuse block mounted, and I've got those wired together. And now from the fuse block to the battery, another fuse block for that entire fuse block. This is a single fuse. The fuse block that's already in there is for multiple fuses, and it's where I'm going. It's going to be my unswitched positive distribution. So anything that comes into the battery, like chargers I want to put in there, or anything that needs to go out of the battery that can't be switched, like a bilge pump, stuff like that. So anything that is unswitched would go into there. And so this one takes a bigger fuse and some bigger wire, so I also picked up some bigger wire. All right, so here's where I'm at right now. I got the fuse block. Okay, maybe we can see this a little bit better down here, but there's the fuse block, and I've got the fuse block, and the red and black wires over there go to the charge controller, which is right over there, and then the charge controller is going to go over here to this DIN rail, which is where the shutoff switch is going to be. And then from here, the negative's already hooked up. The positive is going to be down on the bottom. The positive is going to come over here to this space right there, that empty space. And there's going to be another fuse block, a larger fuse block, that's for this whole thing here. So there's going to be a fuse block there. It's going to go through that hole there, and then over here to the other side to the positive on battery 1 right there. And that's where all the positives will come from on the battery, or on the parallel bank. Next part is mounting the darn panel. I got the wires here that are supposed to go from the panel into this shutoff switch, and the panel is going to be outside there. I got to route these from outside to inside, and I was thinking I was going to have to drill a hole in the boat, and in fact I bought some of these cable entry glands, thinking that I was going to have to do that. These ended up being too large, and I actually, looking around, I found a hole that was already drilled, because I believe this boat had solar panels before. So on the stern and the transom of the boat, there's a hole that is drilled, and then there was one of these little things, this little cover up thing over the hole, so it faces down like that so water doesn't get into it. But there was no sealant or anything on it, so I'm not sure it was really helping keep water out of the boat. But at least it was on a vertical surface versus a horizontal surface. So what I'm going to do, I'm going to go ahead and route those through there, and then put this back on and seal it up real good with butyl tape. Then the other thing I bought this week were these things here. These are going to clamp onto the rail, and then the solar panel will screw onto these. So what I think I'm going to have to do, though, is the panel, it's a big mess in here right now, but the panel's sitting right over there in the box. And I think what I'm going to have to do is I may have to get a couple pieces of aluminum flat stock and bolt it to the back of the panel, bolt this to the aluminum flat stock, and that will give me, let me adjust it some so I can get that mounted on there. So that is where I'm at right now. I'm at the end of day 2 of this project. I'm getting ready to pack up and leave here. I'm going to come back tomorrow to continue to work on this and try to get the panel mounted. Alright, so I've got all the wiring done for the solar panels. So the way this ended up, everything worked as expected. with a couple of minor hiccups here and there. I ended up changing the location where I put the wires into the boat. Instead of drilling a new spot, I found an old spot, used that. So that ended up meaning that the wires that I bought were too short. So I ended up having to bring them into the boat, put them into a terminal block inside the panel area, right behind the panel area over there. So I put a terminal block in there, brought the solar panel wires in, and then did another run from there down here into this compartment. So I'm going to show you everything all hooked up here. So what I've got first is this thing right there. That's the breaker box. So I can disconnect the panels. So the panel wiring goes from outside directly to here by way of that terminal block, and then I can shut the panels off and on right there. So then over here, that goes from there over there to the charge controller, and you can probably see that the charge controller is blinking blue. I don't know if you can see that from there, but it's blinking blue, which means it is on. So then from there it goes over to this fuse block here, and there's the positive section on the bottom and the negative section on the top. And then from there, the negative goes to the battery, and the positive goes to another fuse block right over here. And this is a larger fuse block, so this thing here can hold up to 100 amps. So that that charge controller right there has an amp rating, or you're supposed to put a 20 amp fuse on it. So that fuse right there in the fuse block is a 20 amp fuse. Then coming over to here, this one is a 70 amp fuse, and that's just so I can add more stuff later. So if I had more solar later, I'll just do the same thing. I'll put another charge controller down here somewhere, and then add that into the same fuse block, and then put it into, or then it'll go into here, and then to the batteries. So as far as the batteries go, I didn't do everything I wanted to do with them, just because it's starting to get out of control for like what I'm trying to get fixed here. Eventually I'm going to have to buy some new battery cables and get all those hooked up. I was able to rewire the battery, so I have all my negatives coming from number 3 battery and all my positives coming from number 1 battery. And then later on, this will be another project that I'll have to go in to straighten up the battery compartment and get all the battery cables that are the same length and going to the right locations. So for now, it's working. Now I'm going to take a look outside, and let's see how that worked out there. Okay, so as I mentioned previously, this rail, this is where the solar panel is going to go, and this is where it's going to plug in, these 2 plugs right there, and it's going to go on here so it can rotate on this pole here. And the wire runs, originally I was going to try to bring it somewhere in here, and I was going to end up having to drill a hole somewhere in this area here, but thank goodness I didn't have to, because if you come back here, and I ran the wire all along here, down the back, and then back here, and let me see if I can get this, right here is where they go into. So this was here before from a previous solar installation. I have some butyl tape in here that's settling there, so I'll have to get that cut away once that's done. But I brought it into here. This spot was already here, so I didn't have to add any more holes in the boat. And this little flashing thing was still there too, but I packed that thing full of butyl tape to keep water out of the bottom of it, and then put butyl tape around the outside to seal that as well. So last thing I've got to do, here's the panel. I got to take it home because I got some of this flat bar stock here. I'm going to have to cut some pieces of this, mount it to the back of the panel so I can put the clamps on to the bar stock. So I've got that all marked out on there, where the clamps are going to go, and where I need to cut it. And then I'll bolt that to the panel, bring the panel back, and then put it on the rail. Okay, so I've got the panel plugged in just to give it a test. So I got to go flip the switch and see what happens. So I've already connected the Victron charge controller to my phone through the app. So I'm going to go ahead and connect that again, and then it's Bluetooth, so I can go on here. It automatically shows up as being on here. So right now you can see I got the app here. It says I've got 0 watts of solar. It tells me the battery voltage, which is about 13 volts right now. So what I want to do is I'm going to flip the breaker, which means I should have solar power coming from the panel, and see how many watts that comes up to. Assuming nothing explodes, here goes nothing. Ooh. So right now, just it's sitting out there. I've got 3640 watts of solar coming in at 14, 15, 17 volts, 2.2 amps charging, and my battery voltage, there we go, and it's charging up the batteries right now. So the solar panel does work. I got lights on, a steady blue light on the controller, which I think is what I should have, but everything looks like it's working. And there does not seem to be no sparks, no smoke. I think the solar project is done.